Man has been studying space around our Earth for the past several thousand years. In this comparatively short period by astronomical standards, we have managed to discover a great many riddles lurking in the cosmos. Most of them can be theoretically described to this or that degree. However, others defy our understanding completely. One of these mysterious things lurking in space is the dark flow, which may rightfully be called one of the most amazing mysteries of the universe. Cosmo. The first in outer space. The world around us is full of things we're not quite able to explain today. But it is these mysteries that give people inspiration to create worlds where a fantasy becomes a reality. One of these worlds can be enjoyed in the game Raid Shadow Legends, where you can join any of the 13 factions. Personally, I am quite fascinated by the High Elves. Their support is said to have helped the forces of good stand against the forces of evil for thousands of years. Now, here is one of my favorite champions, Lysandra. With her amazing skills like Transference, Exhaustion and Energize, you can come off victorious in a fight with many enemies you may encounter in the game. Also, Raid Shadow Legends regularly releases a bunch of great seasonal updates. One of them is the Doom Tower, a giant challenge where you will have to face 12 bosses and also make it through the secret rooms full of amazing goodies. To immerse into all this ambience, you simply have to download this free game from the link below for iOS, Android or PC. This will give you a free Spirit Champion, as well as 50,000 silver, 5 mystery shards and a lot more bonuses. Hurry up, as this present is only valid for a month. You can find it in the inbox in the top right hand corner. The dark flow is a term referring to a probable coordinated motion of galaxy clusters. It was identified back in 2008 when the cosmic microwave background radiation was being studied. This phenomenon is often easy to confuse with the motion caused by the Great Attractor. The dark flow, on the other hand, is a unique process whose nature is quite baffling and elusive. According to the standard cosmological model of the universe, the motion of galaxy clusters is supposed to be random and chaotic. This is deduced from the fact that all objects in space are located in their unique places, and none of them have masses completely identical to others. However, not so long ago, a collected motion of at least 1,400 clusters was discovered in the universe, and the reason for this anomaly is still not identified. The discovery was made thanks to the analysis of data collected by the Wilkinson Microwave Anisotropy Probe, or the WMAP, whose mission was to study the CMB radiation. The discovery was made possible thanks to these people: Alexander Kashlinsky, Fernando Atrio Barandella, Daniel Kotsevsky and Harold Ebeling. In order to register this phenomenon, the team of scientists collated the WMAP data and X-ray observations. And so it turned out that certain galaxy clusters move at velocities reaching 1,000 km per second in the direction of a certain area of space, aiming to cross the border of a cosmological horizon. The flow stretches for up to 3 billion light-years. The process should be exclusively accounted for by the presence of a large object in that area, whose mass must be bigger than the total mass of a really great number of star clusters. It goes without saying that this value must be extremely big, as the average mass of one cluster is a staggering 10 to the power of 14 solar masses. If this really is the case, here is the first paradox we're faced with. In order to reach the border of the observable universe and go beyond it, one has to move at superluminal speeds, which according to physical laws is impossible. Besides, the Big Bang theory implies that any cosmic structure is supposed to be distributed evenly. That is why there is no way there is a sole celestial giant out there beyond the boundaries of the observable universe. If, however, this assumption proves to be correct, then we are faced with a truly unique anomaly, whose nature should be explained by a completely different set of laws. When attempting to account for the phenomenon of the dark flow, scientists had to question certain points in the Big Bang theory. Supposing the newly born universe used to be comprised of a multitude of spheres, the matter at hand assumes a totally different aspect. and then the existence of phenomena like Solar gargantuan objects would be feasible. Some scientists believe that at some point in the distant past, our part of the universe could hypothetically have been something like a giant sphere tucked away among a great number of similar ones. Then it exploded and rapidly began to expand. The explosion in question could have been the hypothetical Big Bang, and the growth of the sphere could be what is now known as the expansion of the universe. According to a few finer points of the same theory, the former sphere, that is our part of the universe, has not lost all of its former properties and continues to interact with other universes, the latter being of the same shape. And it is this interaction that causes star clusters to move in what we now call the dark flow. This description of the universe is of course just another attempt to account for this episode of its evolution. Any concrete information about it is effectively unavailable. Nevertheless, it is studying anomalies that is able to reveal the most puzzling nuances of this process. There is another hypothesis about the nature of the dark flow put forward by cosmologist and theoretical physicist Laura Mersini Houghton, the University of North Carolina. According to her, the dark flow may be indicative of the existence of a parallel universe. The towers used to be connected with on a quantum mechanical level billions upon billions of years ago, and then at some point it broke free as a result of the Big Bang. This way, the dark flow could have to do with the rupture in the outer wall of the universe's structure. This rupture would have been formed as a result of our hypothetical detachment from another universe. And as for the dark flow itself, what we see is matter flowing through the rupture. Unusual as it is, even though this hypothesis may not be supported by all astrophysicists around the world, at least the possibility of the existence of something out there beyond our understanding of the universe's laws isn't dismissed as too fanciful or incorrect. For example, the prominent theoretical physicist Stephen Hawking went as far as to build a mathematical model, proving the hypothetical possibility of there being a multiverse containing a great number of universes similar to our own. But in order to find out in which of the proposed hypotheses its author is likely to have hit the nail on the head, we have our work cut out for us. First, we must define what all space around us is made of. There are two basic principles regular cosmological models are based on. The universe is isotropic, that is, it has been developing in all directions and must have a spherical shape, if any at all. And it is homogeneous, that is, it has no directions or shape. Isotropy means uniformity in all orientations, while anisotropy means that properties vary with the direction from which they are measured. As for homogeneity, it means uniformity from point to point in space. It could be illustrated in the following way. Wherever you were to find yourself in the universe, the space around you would be more or less the same. Consequently, the universe is isotropic and homogeneous. However, if on your journey through the universe you were to bump into a great body of matter moving in some direction or other, this would mean that some parts of the universe are anisotropic. Thus, the cosmological model would not apply to those areas. The cosmological principles effectively define the foundation for physical laws. For instance, if the universe is homogeneous, physical laws would apply in any part of it wherever you were to gauge them, and large-scale structures like the dark flow are actually not supposed to exist in it. There is also the universally accepted theory of a hierarchical universe. According to this theory, originally all large objects in space used to be tiny, but as time passed they merged, thus growing to form enormous galaxies. However, on discovering the dark flow anomaly, we realized that these phenomena don't fit in the general picture. The dark flow isn't supposed to exist in the model of an isotropic universe. Apart from that, this phenomenon isn't the only example of a structure this large and inexplicable. For example, here are a few more large-scale structures which are not homogeneous and which by far exceed the estimated maximum size, which places them at odds with the general cosmological principles. The large quasar group spotted in 1991, measuring 580 megaparsecs, the Sloan Great Wall discovered in 2003, measuring 423 megaparsecs. The Hercules Corona Borealis Great Wall measuring a staggering 10 billion light-years. All these objects urge us to question the generally accepted theories of the origin and evolution of our universe. And by the looks of it, the dark flow could prove to be the most exciting of all. The mere assumption of its existence prompted a number of new hypotheses about what the observable universe is made of. If there is a motion of galaxies taking place in it, and this movement is heading in a particular direction and is not random, this means that the universe is able to move in some direction or other. It means that assumptions that there are huge irregular structures beyond the cosmic horizon may hypothetically be correct. Be it as it may, today all these thoughts and ideas are confined to theories only, and it is going to take a lot of time to prove them true or false. But even if the dark flow becomes a common truth, it is a foregone conclusion that it will only spawn a new panoply of riddles. In spite of the fact that mankind has come a long way in exploring and studying the world around us, the phenomenon of the dark flow is yet another confirmation that our knowledge today is only a tiny portion of the supreme knowledge, and there is an infinitely longer way to go yet. Until only recently, people used to believe that the basic principles of the universe are the irrefutable truth. Today, however, with every new anomaly discovered in outer space, this idea is becoming less and less convincing. And for all we know, the new generations may well perceive the universe in a completely different way.